All right, so rational expressions. Okay, so you dealt with rational numbers before, right? So let's remember what a rational number is. A rational number that you're more familiar with, like 3/5. 3/5 is a rational number. Remember when we defined a rational number is defined to be the quotient of an integer and an integer. 3 is an integer, 5 is an integer. -7/3, that's a rational number. All right, so -7/3 is a rational number because you have an integer, -7, and an integer, 3. So those are all rational numbers, but notice they look like fractions. They're fractions, right? So here are examples of rational expressions. So remember that both of these have the word rational in it. Now, this itself is still considered a rational expression right here. These are rational expressions. But the rational expressions you're going to be dealing with will have variables in it. So here are examples of rational expressions, like x plus 1 divided by x minus 3. Those are rational expressions. I have a fraction. There are variables involved. X squared plus 3x minus 5 divided by x plus 2. Rational expression. 5 divided by x minus 6. Rational expression. 3 divided by 2x. That's a rational expression. Now I'm going to go back to the rational number that we talked about earlier, and I'm going to ask you, is 8 a rational number? Yeah, because I can write it as 8 over 1, couldn't I? I can also write this as 16 divided by 2 if I wanted to. So going back over here, x plus 5, even though it doesn't look like a fraction, although you can write it as 1, that's a rational expression. Because isn't x plus 5 the same thing as saying x plus 5 divided by 1? Now, the true definition of rational expression is this. A rational expression is a polynomial divided by a polynomial. So when we talked about a rational number, we said that the numerator and the denominator were integers. For rational expression, the numerator and the denominators are polynomials. So all these are polynomials. X plus 1 is a polynomial. X minus 3 is a polynomial. X squared plus 3x minus 5 is a polynomial. X plus 2 is a polynomial. 5, even though it's a monomial, it's still considered a polynomial. A polynomial is one or more terms. One or more monomials. X minus 6 is a polynomial. 3 is a polynomial. 1, it's a monomial, but a polynomial is one or more monomials. All right? So those are all examples of rational expressions. Now, one of the things you have to be able, and you're going to, next semester in college jobs, you're going to have to deal with rational expressions. But they'll be more in terms of rational functions next semester. So next semester they'll be considered, you're going to be dealing with rational functions. Here we're dealing with rational expressions. One of the things you have to be able to do with rational expressions is to evaluate them. So you need to be able to evaluate rational expressions. So being able to deal with rational expressions in this course will help you to be able to understand rational functions and what you need to be able to do with them next semester. Now, the way you evaluate rational expression is the same way, for the most part, that you evaluated what you turned in today. So remember, one of the things you turned in today was this. Suppose that f of x is negative 2x squared plus 3x minus 1. Now that's a quadratic function. That's function notation. Next semester, you're going to be writing this in terms of function notation as well. But for right now, it's just expressions. So next semester, you'll see something like f of x equals this, g of x equals this, k of x equals this. What you had to deal with, one of the things you turned in was something like this. Suppose I wanted you to find f of negative 3. What'd you do? And I think you had this on your first test or something similar on the first test. What'd you do to evaluate this function when x is negative 3? Yeah, wherever you saw the variable x, you plugged in, you substituted negative 3. And so you said, well, f of negative 3 then would be negative 2 times negative 3 squared in parentheses plus 3 times negative 3 minus 1. And then use the order of operations. Remember, you get order of operations with regards to what we have here, you had to do exponents first and then multiplication. What's negative 3 times itself?
9.
And 9 times a negative 2 is a negative 18. Here, that's going to be a negative 9 and then minus 1. And so remember, you got to add and subtract from left to right. So when I go from left to right, what's a negative 18 and negative 9? Negative 27. And what's a negative 27 and a negative 1? Negative 28. So f of negative 3 would equal a negative 28. So the idea here was that where we saw the variable x, you substituted negative 3, right? The same idea is going to apply when you evaluate rational expressions, although they would not be written in function notation. So here's what you have to be able to do at this point. So let's assume, in our case, that a is 2, b is negative 3, and c is negative 2. So a is 2, b is negative 3, and c is negative 2. And you want to evaluate each of the following. Okay, number 1. Suppose I had the rational expression a minus 3 divided by b plus 5. A minus 3 divided by b plus 5. So if I'm going to evaluate this rational expression, just like I did this quadratic function right here, where we see the variable a, what do I substitute? 2. Where we see the variable b, what do I substitute? Negative 3. So it's just a matter of plug and chug. So I'm going to plug in the values, I'm going to chug them to find out what the values are, the computation is. So a is 2, so I'm going to say 2 minus 3 divided by b, and what's b? So I say negative 3 plus 5, and now let's chug. So I'll plug, now I'll chug. What's the numerator? Negative 1 over, and the denominator is 2. So there's your answer. So that expression, that rational expression, is equal to a negative 1/2 when a is 2 and b is what? Negative 3. All right, number 2. Suppose I had b plus 5 divided by b squared minus 2. B plus 5 divided by b squared minus 2. So in this case, what do I substitute? And there's only one variable here, b. What do I substitute? Negative 3. So I get negative 3, so you're just plugging right now. Negative 3 plus 5, that's the numerator. Now remember, you have a b squared in there, so you really need to put that in parentheses, what b is in parentheses. So that's negative 3 in parentheses, and I'm squaring it. And whatever that is, I'm going to subtract 2. What's the numerator? 2. Now, order of operations, I square before I subtract. What's negative 3 times itself?
9.
And so what's 9 minus 2? 7. So that expression is equal to 2 7s. All right, number 3. Suppose I had a squared minus 3a plus 2 divided by 6 minus 2b. A squared minus 3a plus 2 divided by 6 minus 2b. So wherever I see the variable a, I substitute 2, and the variable b, I substitute negative 3. So I get in parentheses 2 squared minus 3 times a in parentheses, write as 2, plus 2, right? All divided by 6 minus 2 times in parentheses, what do I put?
Negative 3.
Negative 3. All right, let's get the numerator. What's 2 squared?
4.
4. A negative 3 times 2,
Negative 6.
and then plus 2, right? The denominator, 6, and then what's negative 2 times negative 3?
Positive 6.
Plus 6. What's the numerator? No. Numerator. 0, right? What's the denominator? 12. Now, don't leave it like that because I expect you to know what 0 divided by 12 is. What's 0 divided by 12? 0. So that rational expression is equal to 0. All right, and then let's look at number 4. Suppose in number 4, I had c plus 1 divided by 2c squared plus 3c minus 6. So c plus 1 divided by 2c squared plus 3c minus 6. So wherever I see the variable c, and there's only one variable in here,
Negative 2.
I plug in negative 2. So my numerator, I get negative 2 plus 1. The denominator, I get 2 times c, which is negative 2, but what am I doing to that? Squaring it? Plus 3 times c, which is negative 2, minus 6. What's the numerator? That one's easy. Negative 1. All right, let's talk about the denominator. So what's negative 2 times itself? All right, and so this 4 times this 2 gives me 8. And 3 times negative 2 gives me negative 6, and then subtract 6 as well, right? What's 8 minus 6? And what's 2 minus 6? Negative 4? But don't leave it like that. If you leave it like that, it kind of implies to me you really don't know that a negative divided by negative is a positive. So you need to give me the answer of 1/4. Okay? All right, now